Hello everyone, welcome back. In this video we discuss about shift reduce parser. Shift reduce parsing is a process of reducing a string to the start symbol of a grammar. It means, so from the given string we are reducing to the root node or start symbol. Okay, so to perform this shift reduce operation, it uses stack and input buffer. Why we have to use a stack? Stack, it is used to hold the grammar, and input buffer or input tape, it is used to hold the string. Okay, so in the previous video I have shown this diagram, LR parsing algorithm. Okay, it requires input, stack and the parsing table. Okay, so here in the previous video we have constructed the LR0 and SLR1 parsing table. Okay, so now after constructing the parsing table, whatever the string we have generated from the grammar, then we are going to put input string into this input tape, and the grammar left side variables will be taken into the stack. Okay, so that is how it performs. Let us discuss here. Okay, so here I have considered the previous parsing table for LR0 for the same grammar. Okay, so let us first number these grammar. This production is 1, 2 and this is 3. Okay, so now first generate the string. Okay, so you can generate any string. So here I am going to generate S implies AA. So here there are two variables and this variable is having two productions, so you can use any one of the production. So in order to increase the length of the string, instead of using this one symbol, I am going to use this production, that is AA, and this A remains as it is. So once again here I am going to use the same production AA. I will replace this A by AA and this is A, and finally this A I will terminate it by B, and again this A terminated by B. So totally we have generated 2 A's and 2 B's. Okay, this is the language, minimum language I have generated from this given grammar. And you know that whatever the string you generate, that string must be end by the dollar symbol. Okay, so now after once the input string is taken into the input, finally this stack, and the top of the stack we should hold the start symbol, because here we are constructing the bottom up parser. So we are constructing leaf node to the root node. Leaf node contains only the terminals, and root node contains the start symbol S. In between root node and the leaf node there will be a interior nodes. Okay, so that interior nodes, everything will take place between doing the shift reduce operation. Okay, so here the given string is AABB. Okay, so now once this string is taken into this input tape or buffer, so here there will be it introduces the input header. This is going to point the very first input symbol. Once this input symbol is scanned or read, then it will move to the next input symbol. Okay, and then moves to the next input symbol. Once if it reached the last input symbol in the input buffer, then before going to read this input symbol, then one step it comes back, and it is going to reduce the previous input symbol. It will reduce the previous input symbol. How it reduce the previous input symbol? Here reducing is nothing but what? Replacing the terminal by the left side variable of that production. Replacing the terminal by the left side variable of that production. So which one you are replacing here? This input symbol B you are replacing. Okay, so it means that what? This input symbol B must be appear in the right side body of the production. Okay, in which production this input symbol B is present in the right side body of the production? Here in this production number 3. In the production number 3, this right side body of the production contains only one terminal B. So here this B is going to replace it by the left side variable, So that is here I am replacing this A by B by A. Okay, so now the grammar, the input symbol or input tape contains what? A, B. This B is replaced by A. Sorry, not this. This is replaced by A. Previous one. Okay, last but one. That is A, this A and B. Okay, and now what is A here? Okay, so now again when it points to this A, before scanning this input symbol B, once again it checks this previous input symbol. Is it possible to replace those input symbols by the left side variable or not? Okay, so it will check whether those symbols are present in the right side body of the production in the given grammar. So here this is A and this A. So only A is present in the body of the production. Is that A is present in the right side body of the production? Only single A variable? No single A variable is present here because there is no unit production here. Okay, then it is going to take the next previous input symbol. What is the previous input symbol is A. Then when it consider this A and this, so it will check these two symbols are present in the right side body of the production or not. Yes, there is a two symbols present in the right side body of the production. Then it is going to replace these two input symbol by the left side symbol. What is the left side symbol? That is variable. Again these two A, terminal A and the variable A will be replaced by A by using the production line number 2. That is A implies AA. Okay, and still it has to scan the last input symbol. Okay, again before scanning the input symbol, again there is A is present. Once again by using the same production rule, this A and this A will be replaced by A. So finally in the stack it has only A and the B. So now this can't replaced by the left side variable because this is alone not present in the right side body of the production. Then it is going to read the last input symbol. What is the last input symbol? Is B. So once this B is shifted onto the stack, then immediately it will check is it possible to reduce this B by some other left side variable or not. Of course we can reduce it by A here. So at last this A, B is replaced by A. And finally only two variables are available in the stack. Again these two variables are replaced by using the very first production, that is S implies AA. So here it is what? Have you reached the start symbol? Okay, from the leaf node to we have reached the parent node, that is the start symbol. So that is how the same steps are going to use in the shift reduce table. Okay, so here I have considered the LR0 parsing table in order to do the shift and reduce operation here. Okay, so now here I have considered the same string and taken in the input tape. Okay, and you know that initially the stack should be represented by the dollar. When the stack is empty, so that is represented only the dollar that is present in the bottom of the stack. So after the dollar, okay, when the stack is empty, after this dollar it is going to shift. Before scanning any input symbol, it will shift the start state, okay, or initial state, or the first state. What is the first state here? 0. So here this 0 will be calling it as start state or initial state. So that start symbol, the start state will be pushed onto the stack. Okay, so that is how I have written here $0. So now the stack contains the, I'll write here, okay, dollar. So now the stack contains the 0. So this represents the top of the stack. Okay, so being the 0 state, it is going to see the very first input symbol which is present in the input tape. What is the first input symbol? First input symbol is A. Okay, now 0. Okay, so to perform shift and reduce, we can use this table, parsing table. Okay, so where the machine is initially in the initial state. So being in the initial state, it is going to see the first input symbol A. 0 on A. What it is doing the action? It is shift. It is saying that shift. Okay, shift to which state? To the state 3. So now here shift 3, what it indicates, you are going to push the first input symbol A along with the number of the state. Which number means it is going to from this state, after seeing that input symbol, it is going to the state 3. That is the meaning, right? So now here what it is going to do is shift. What it is saying, you shift the input symbol along with the state number. 2 elements you have to push onto the stack. So that is after pushing both the elements 0, A and this 3. Okay, so that is how A and 3. So now after shifting the first input symbol A onto the stack, so remaining string present in the input tape is only A, B, B and dollar. Okay, so now what is the top of the stack? Top of the stack is state 3. Okay, state 3. We have to go to the state 3. Okay, state 3, because from the state 0, after seeing the input symbol, it has moved into the state 3. So now the machine is in which state? Machine is in the state 3. So being in the state 3, it has to read the next input symbol. What is the next input symbol? Next input symbol is A. Okay, so 3 on input symbol A. Again there is a self transition. Okay, if you want, you can just check it, the transition diagram of this grammar what we have constructed already in the previous video. Okay, so 3 on A, it is having a self transition. Okay, once again it is saying that do the shift 3. Okay, so now after shifting the next second input symbol onto the stack, now the stack status will be $0 A 3. This is the first input symbol, and another second input symbol is A 3. Okay, so once again we have pushed onto the stack. So now after pushing the second input symbol onto the stack, and then the remaining input symbols present in the input tape is only BB dollar. Now what is the top of the stack? Top of the stack is 3 on input symbol B. So being in the same state, it is going to see the next input symbol. So what is the next input symbol? 3 on B is again shift 4. Shift 4 means push the third input symbol B onto the stack also. Then the stack status will be A3 and B4. A3 and B4. So after pushing the third input symbol, it remains only the last input symbol B dollar. So here what I said, so here before scanning the last input symbol, it is going to reduce the previous input symbol by the left side variable. Let us see here. This we should see the reduce operation. Okay, so now what is the top of the stack after pushing B? Now the top of the stack is 4, right? Same 4 on input symbol B. Go to the state 4 on input symbol B. What it is? Reduce. Okay, as I said already, it is going to do the reduce by using which production? R3. R3 means it is the 3 indicates what? The line number of that production in the grammar. Okay, what is the line number 3? Line number 3 here, A implies B. Right? So that is, it is telling that do reduce 3, right? Reduce 3, 4 on input symbol. So now reduce 3 means it will pop the 2 elements. Why it has to do pop? So here one point you remember, shift is nothing but push. Reduce is nothing but pop. Okay, so it is going to pop the element B. So along with this element B, it is going to also pop the state number. State number means in order to reduce one element, it is going to remove the two elements from the stack. Input symbol B along with that respective number, state number of that. So that is 4 and B will be removed, means popped, and then that will be shifted by the left side variable, that is $0 A3 A3. We have popped these two elements and replaced by A. The still the input tape contains B. Okay. So now here it is what? Variable A. Now the top of the stack contains A. So now A, below that A, which number is present? State number 3. Below that state number 3. We have to see 3 on A, because this A is not a state. Can't read the or can't scan or read the input symbol, right? So now 3 on A. We have to check it. 3 on A. Go to the state 3 on A. On A is what? On A it is 6. That is shift 6. Shift 6. That is $0 A3 A3. Okay. So A6. A6. It will shift. Okay. Still tape contains B $. Now what is the top of the stack? Top of the stack is 6. 6 on B. Go to 6. 6 on B is what? It is telling that do reduce using the line number 2. Production line number 2. What is the production line number 2 is? A implies A. A implies A. Okay. So that is reduce using the line number 2. Reduce using line number 2. So now the $. Okay. So using reduce number 2 means how many elements are present in the right side body of the production? There are 2 elements. So in order to eliminate pop 2 elements, it is going to eliminate how many? 4. How? Eliminate input symbol along with the state number, right? Along with the state number, it becomes 4. So for A, what is the state number? 6. A means your variable. For variable A, state number is 6. For input terminal A, the state number is 3. So it is going to pop these 4 elements. Okay. So when it eliminates this, then it should be replaced by what? Left side variable. That is $0 A3, and these 4 elements will be reduced by A. So now input tape contains only B $. Okay. So now 3 on input symbol A. 3 on input symbol A. Again, once again, go to the state 3. We are using the same production. 3 on input symbol A is 6. That is shift 6. We are shifting only the state onto the stack. That is $0 A3 A6 B $. So now 6 on input symbol B. 6 on input symbol B, again it is telling that do the reduce by using the same production number 2. Okay, production number 2. So now how many element? Production number 2, right side there are 2 elements. So we have to eliminate or pop the 4 element. So A with state number, this terminal A with the state number. So now the $0. So this is replaced by A. Okay, then B $. Okay. So now 0 on A. 0 on state 0 on A. Okay, it is shifting 2. Shift 2. Okay, 0 on A is shift 2. Right. $0 A2. Then state. Input state is B dollar. Now 2 on input symbol B. Go to the state 2. 2 on input symbol B is what? So now we are going to read the last input symbol. So first we push this input symbol B onto the stack. Okay. And then we are going to pop it. Okay. Shift 4. Now $0 A 2 B 4. Now the input state contains only the dollar. Okay. Now what is the top of the stack? Top of the stack is 4. Now we have to check 4 on dollar. 4 on dollar. 4 on dollar is what? Reduce 3. Reduce using the production number 3. So this last input symbol again it should be replaced by the last input symbol. This should be again replaced by left side variable A in order to reach the start symbol. Okay. So now reduce this B by the left side variable $0 A 2. This is replaced by A. Now dollar. Okay. Now 2 on A. 2 from the state 2 on A. We should see the go to table. That is shift 5. Shift 5. Okay. $0 A 2 A 5. Okay. So 5 on dollar. 5 on dollar is reduce 1. Reduce 1. I'll continue here. Okay. That is $0. Okay. Reduce 1. So reduce 1 means what is the first production? Line number 1 production S implies AA. How many variables are present in the right side body of the production? There are 2 variables. Okay. So now these 2 variables are replaced by the left side symbol. Okay. So reduce means pop. I am going to pop this A with respective state number and this A with respective state number, and these 4 are replaced by the left side symbol. What is the left side symbol here? It is yes. Okay. This yes. Right. And then dollar. Okay. Dollar. So now yes. Okay. Yes. Right. 0 on yes. 0 on yes. What is 0 on yes? 0 on yes is 1. 0 on yes is 1. So shift 1. Shift 1. So now $0 yes 1 dollar. So now 1 on dollar. 1 on dollar is from the state 1. 1 on dollar is accept. So finally we have reached the accept here. Okay. Once if you reach the accept, then it means that the string has accepted. The string has accepted means from this leaf node 2, from this leaf node 2 you have reached the start symbol yes. When you reach the start symbol yes, it means the string has rejected. If you are not reached the start symbol yes, it means that string has rejected. So this is how we write the moves for the given string using LR0 parsing table.